Good afternoon to all everyone.
Good afternoon to all everyone. Good afternoon to all everyone. Good afternoon to all everyone.
I welcome you all in the 10th day of 2 week short-term training program on alternate source of sustainable development. Now, I am going to introduce the first speaker of today's session, Dr. Surendra Kachhwaha sir. Dr. Surendra Kachhwaha sir is working as professor and head of mechanical engineering department in School of Technology, Pandit Deen Dayal Petroleum University since May 2011. Professor Surendra sir completed his BE Tech degree in mechanical engineering from MBM Engineering College in Jodhpur in 1985 and MTech in 1988 from in heat power from IIT BHU and PhD in evaporative cooling from IIT Delhi. He is also performing his duty as Dean, Faculty of Engineering and Technology, and has a teaching experience of more than 23 years. He has worked 17 years at Engineering College, Kota, and successfully completed the tenure of 6 years at Delhi College of Engineering, Delhi. He has contributed in more than 80 technical publications in reputed national and international journals and more than 100 publications in national and international conferences. He has successfully completed various research and consultancy projects sponsored by government agencies in last 2 decades. He is a recipient of Young Scientist Award 1998, SERC Visiting Fellowship 1999, and INSA Visiting Fellowship in 2003 due to his applied research contribution. Recently, he has received a grant of 1 million US dollar to establish an advanced center for biofuel studies at Pandit Deen Dayal Petroleum University. His area of interest are evaporative cooling, ice slurry generation, trick generation, geothermal power generation, biodiesel production techniques, and wind energy. He has guided several PhD scholars and MTech students in diversified areas of renewable energy. Now over to you, sir, please.
Welcome, sir. Though I think he has missed some of your experience years. Now you might be having 30 plus years of experience. Welcome, sir. You are unmuted. Please unmute, sir. You are muted.
Sorry, I have unmuted, and I think now I am audible.
Yes, sir.
Yeah. The deliver a lecture on behalf, we can say, and DTU. It is just like again homecoming. All my colleagues are known to me, and I'm thankful to Dr. Paul, who has invited me for this one. And energy point of view, can say DTU is working very hard, and a lot of contribution is there to create awareness regarding the energy and energy-related issues. So I hope this program was very, very valuable for the audience. And today, let me give a warm, like I say, this on the festival occasion. Everybody has celebrated this Makar Sankranti and Onam with great fervor and enthusiasm, and hope that this negative effect of Onam and other things would be minimized at the earliest as possible. Let's hope for the best and let us be positive. At the same time, I request everyone that this should be safe and attentive, and just, like I say, use the mask everyday life so that we can be, like I say, we can avoid from the COVID like disease. So with this one, I can say, Paul sir, should I upload my slides?
Yes, sir. Yes, sir.
Yeah. I think through. Yeah. Paul sir, my slides are visible?
Yes, sir. These are visible. Please make it full screen.
Yeah, sure. So that I will do. Yeah. So now it is on full screen, and the Delhi Technological University, and particularly Mechanical Production and Industrial and Automobile Engineering Department, and on behalf of the Center for Energy Environment, The 2-week short-term training program has been conducted, and I wish a great success for this program. And those who are listeners, they might have, I can say, got a very valuable information from all the experts. Now, you might have talked, I can say, you might have listened various uh, personalities and other things related to the energy sustainability, and particularly the topic is alternative energy sources and the sustainable development. In this particular regard, uh, this time I am just presenting, this is a collection work in which I will just present the recent biotechnological applications of waste cooking oil. Actually, the last decade with Professor Paul and when I was in DTU, we have started working in the case of waste cooking oil. Couple of test apparatus are there, and we have very good publications in that area. At that time when we have started working, we have focused in case of converting the waste cooking oil into biodiesel. But Kashi, this is only one energy applications. There are huge number of applications are there where waste cooking oil can be converted into very, very valuable products. In my today's lectures, besides the can say fuel applications, I will talk about the non-fuel applications where waste cooking oil, which is available in large source, can be converted into various different other applications which are equally important compared to the biodiesel. Uh, I will talk about what is the basic motivation for this, can say this waste cooking oil related to work, and always policies play an important role. And based on the policies, our research work was to guide it. And national policy is very clear regarding the biofuel and particularly biodiesel in particular. And then I will just talk about the novel pathways for the biotechnological reutilization of WCO using various strategies and technologies, then other biotechnological applications of WCO. Besides this, remember that suppose for 100 kg of biodiesel production, around 10 to 12 kg glycerol is also produced. This is a major important byproduct, and through this biodiesel route, this glycerol and crude glycerol can play a major role byproduct of biodiesel. And what are its applications? I can say people are still, I can say, the challenge for the researchers, and what are the recent developments. I will talk about that one. And with this talk, let us, can say, finally, I will conclude with key conclusions and the future implications of this waste cooking oil. Now, as far as the motivation is concerned, we all know that waste cooking oil is generated when edible. I'll just convert it to, let me use my cursor so that will be much easier. Yeah. You see, WCO is generated when edible vegetable oils are employed to fry food items in households, hotels, restaurants, and other catering outlets. And once it is fried, you cannot use it second time. That's very important. Otherwise, what will happen? It will have very harmful effects. But unfortunately, what happens? The large volume of generated WCO causes deleterious health effects on human animals when consumed and harms the environment when not appropriately disposed. Normally, it is disposed in the drains and other things, which has a serious impact on the environment. In many cities, particularly small cities, WCO is disposed into sewers, drains, open spaces, rivers, forests, where they generate offensive odors, blocked drainage, damaged concretes, and contaminated terrestrial and aquatic habitats. Now, main issue is that when we have inappropriate disposal of WCOs, it will result in foam formation, increase in the organic load on water sources, hinder wastewater treatment, reduce dissolved oxygen concentration, and totally it will disturb the ecosystem balance. You can say it has a utility, but if you don't use it properly, it will have a lot of serious implications. So therefore, to minimize the harmful impact on the ecosystem, appropriately strategize for proper management. There must be a proper management. Disposal must be proper. Minimization of, I can say this, methods, recycling, conversion, utilization, valorization, and remediation of WCO need to be developed. All these methods are very, very important, and they should be optimized so that the yield, whichever the process we follow, the yield should be maximized for that one. Now, many easy and innovative routes of resource recovery and optimization is converted waste to valuable raw materials. Our policies are very clear that how to convert the waste into valuable raw materials. And from that one we can get a very value-added products to the process of waste remediation, right? Therefore, whole motivation here is that the conversion and transformation of WCO to a manifold varieties of products is one of the low-hanging fruits. Means it is certain that it's not a, can say at TRL level, it's not 0 to 2 or 0 to 5. It is always, you can say, there are many valuable products one can generate by using this WCO, which are alternative for the case of petroleum products, because petroleum products are not sustainable and they can create harmful effects on the environment. From that point of view, we can substitute those products by means of products formed due to WCO. Now, always when we start something on a research or other things, then we have to see that what is the total impact or quantity of that particular product. So from that point of view, just look at, since the WCO is produced from vegetable oils, what is the scenario at national level and at international level, and how does the policy aspects are there. So look at this particular scenario where we know that vegetables are predominantly triglycerides, where the percentage varies from 88 to 98, and an important component of a healthy diet that constitutes about 15 to 20% of total calories taken in most of the industrialized countries. So almost it is an integral part of our food. And if you just look at the quantities, global vegetable oil consumption increases from 150 million metric tons MMT in 2013-14 to about 200 million tons in 2022-2021. So almost you can say 40% rise within 6 or 7 years. In this particular chart, if you look at the main vegetable oil or edible oil which people consume is, can say this purple color, that is coconut oil. Then this particular color, palm oil. In South Asia, very commonly used this one. Beside this one, peanut oil is also there in our country. It is used. The point is that you can see that continuously this vegetable oil is consuming. When the vegetable oil is consuming, then the point is that quantity of waste cooking oil will also increase. So in my next slide, I'll just show you that how much is due to the utilization of vegetable oil, how much is the biodiesel it is increasing. So you can see that different colors are there, but the main hub of biodiesel is Europe, then USA, and South America, particularly Brazil and Argentina. Then from China also a big way, and Middle East, particularly palm oil they are using. Biodiesel production can say reaches up to 800 plus thousand barrels per day, and globally in 2019. And the market size, you can, if you just estimate in terms of dollars, then the market size that was $5.50 billion in 2019 is estimated to be reaching $8.5 billion by 2027. So it means from commercial point of view, it is a huge amount of resource, and how to utilize that resource, the researchers has to accept this challenge, and there are a lot of opportunities for startups and plus converting the biodiesel into many value-added products. Now, how does whenever you can see when we use a particular waste or any quantity and convert it to the product, the policies play a very important role. And in our country, fortunately, the policies are quite good. And particularly in biofuel policies, they talk about the ethanol. Regarding the ethanol, that once you produce the ethanol, can say nowadays they have changed. Earlier, food grains cannot be used for ethanol, but now unfit for human consumption, can say this food grains can be converted into ethanol. Ethanol is a substitute for petrol, and I'll talk it some other day. So by utilizing the ethanol, this 5,000 plus crores carbon, can say this much amount of rupees, the carbon emissions is reduced to the extent of 30 lakh tons. Right. So since today I'm talking about the diesel, so therefore this data is also important related to the ethanol. Now, if I talk about the policies of biodiesel, because biodiesel is a substitute for diesel, whereas ethanol is a substitute for petrol. Now, as per the target from policy point of view, 20% of blending of ethanol in petrol is a target up to 2030, whereas 5% of blending of biodiesel in diesel up to 2030. But unfortunately, you can say biodiesel targeting is falling behind, and even less than 1 is 0.2 less than 0.2 even of the biodiesel blending. The main thing is that what is the source? seeds are not available, Jatropha quantity is not sufficient. In that case, one of the important sources is the waste cooking oil. And we have a lot of hope that proper collection of waste cooking oil through supply chain management, it can be converted into a very valuable product in terms of fuel. And since it creates less pollution, the implementation of BS6 already in April 2020 in NCT Delhi, and sorry, this is for country, and in Delhi it is April 2018 it has started. So now let us look at that. What is the quantity of the source of this, this waste cooking oil? At present, 850 crore liters of diesel is consumed every month in India, right? And objective of the government is to blend 5% of biodiesel in diesel by 2030, right? It means how much it is required? 500 crore diesels of biodiesel, 500 crore liters of biodiesel is required in a year, right? This is a huge quantity. Now, to require this quantity for 5% blending, how much is the waste cooking oil is required? In that case, at present, India consumes around 2,700 crore liters of cooking oil is used, and out of which 140 crores UCO and WCO is the same, unutilized cooking oil. It can be collected from bulk consumers such as hotels, restaurants, and canteens for conversion, which gives around 110 crores liters of biodiesel. 1 million ton is equal to 100 crore liter, right? That's the 2 units commonly used. So now this is the very huge amount of sources there, and from that source, our food agency FSSAI claims that India has the potential to recover 2 million ton or 220 crore liters of used cooking oil for the production of biodiesel by the year 2020. So it is a huge quantity. The fuel point of view, people are working, IOC is working, and a lot of ambitious plans are there. But normally, what happens? It is really a very unorganized sector, and sometimes in village, etc., it is not used properly. In that case, how to utilize the waste cooking oil at local purpose or as a small startup purpose or a household purpose? For that, all the other avenues are there. I will focus fuel as well as non-fuel avenues. Right now, as the title says, that what are the novel pathways for the biotechnological reutilization of WCO using various strategies and technologies. Right here, you see, now this is the era of circular economy. Circular economy means we have to utilize the waste resources, we have to collect properly, you have to reduce it, recycle it, and then again reuse it. In a cyclic way, you have to use it in any process. The input is the input of a process is output of another one, right? So all the processes are connected in such a way, and the minimum interaction of energy, mass, and environment should be there in a cyclic, in the circular economy. Every product must be fit in the circular economy. Then only the sustainable development will be possible. Now, in this whole area, what happens? The main new items, you see here, I have not written anything related to this fuel. Other than fuel, you can say, of course, the first one is the biofuel stock, it is there. Other than this, there are biolubricants. Then bisabolin, a very important component from health point of view and from, can say, health and can say beauty point of view. Liquid soaps, aromatic candles, surfactants, particularly this is used in petroleum products, plasticizers. In the plastics, you can use it and improve the properties of the plastic. Then civil engineering application is asphalt regenerator, where I can say this Damar road and other things, you can utilize this one for life, you can increase the life. Then surfactants. These are a couple of applications where it's still the research work is going on, and lot of, can say we can expect requirement of this conversion of biodiesel for these applications, and they are very, very important in the circular economy. And remember that, I can say, whenever you do the research, one important point is that SDG, that is the United Nations Sustainable Development Goal. Our research and other things should be in tune with these 17 SDG, which some of them are clean water and sanitation, affordable and clean energy, prevention of pollution of aquatic and terrestrial habitats, climate action, and sustainable cities and communities. In those 4 to 5 SDGs, this whole economy of waste cooking oil, circular economy of waste cooking oil play an important role. Therefore, it matches with the policies and targets as defined by the UN Sustainable Development Goals. Now, since it is a large amount, it will certainly contribute in the circular economy concepts, right? And bearing in mind of the increasing quantity of WCO being generated, researchers, industry players, and stakeholders must therefore be kept abreast among trends in the utilization of WCO. So industry must be aware of that. What are the wide range of applications related to WCO? And further, why we have to utilize the other applications? The reason is that there must be a minimization of the effect of WCO on the environment. Further, waste minimization techniques such as waste reduction, waste cycling, and waste utilization should be employed. Now, in this regard, the biotechnological avenues can play a very important role, and in that case, the utilization of WCO leads to waste minimization, reduction of waste disposal cost, and waste utilization for generation of renewable energy sources. The main theme is that waste cooking oil can play a very important role not only for fuel production, but at the same time, wide range of these applications, which I will discuss one by one, and they can play a very important role for MSME, this mini, small, and micro enterprises. It can play a role. Now, when we say that waste cooking oil, when you're utilizing, some important facts we should know. When it is fried, means it is heated at a temperature of 150 and 200 degrees centigrade. In that case, many impurities and its profile, its fatty acid profile changes. In that case, what happens? The moisture infiltration is there, contamination, which causes physical changes, means color changes, viscosity changes, density changes, and chemical changes, means acid value changes, FFA content changes. And these modifications, we should be aware of that one. And there are some severe thermal degradation, which includes polar compounds in the structure. So these changes occurs, right? And the thermal degradation with physical, chemical, and compositional changes through oxidation, hydrolysis, polymerization, etc., lead to the change in some of the properties and saturated fatty acid composition. So it's fatty acid profile changes, and we should be aware of that. Once vegetable oil is converted into this waste cooking oil, then what are its nature which has changed? So ultimately, that as a base, we have to apply it for different applications, right? So in that case, once these properties changes, what are those properties? Density also changes, kinematic viscosity increases, specific heat also slightly changes, iodine value changes, peroxide value, it is also peroxide value, saponification value, moisture content, flash point, number of single and double bonds, and percentage of mono, polyunsaturated components are altered by use. The fatty acids are not given the details, but we all know that once the vegetable oil is converted to WCO, its fatty acid profile changes, and due to that one, the physicochemical properties of the this one changes, right? Now, with this one, keeping this into mind, whenever you go to the application, you should be aware of that, what kind of WCO we are using, and what is its fatty acid profile. Based upon this one, people have worked, and we know that biogas is not a rocket science. Almost we can say we can use the slurry biomass or any type of, we can say, this gobar and other things we are using. In foreign countries, people are using this sewage sludge and pig slurry. And if you use a WCO, right? So in that case, what will happen? Due to for batch anaerobic digestion for biogas production, the performance of pig slurry and sewage sludge improves, because the addition of WCO to the slurries resulted in a low-cost biogas production and improved methane yields. I will not go in the details of that one, but one thing is clear: if you add this biogas with glycerol, the glycerol is also a product of biogas, because they are oxidative in nature. When you use this one, then certainly the point is that biogas quantity will improve and the production rate will also improve, right? So people have done the experiments, and based upon that experiments, they have an outcome that sewage sludge and co-substrate concentrations of 4.6 gram per liter, that is methane quantity, and 8.8 gram per liter is the COD, chemical oxygen demand, respectively, and glycerol, this crude glycerol of X value, fraction of 0.8, were defined to simultaneously boost this cumulative methane production. 91% more methane is produced, and your total methane increase rises threefold increase, right? So it means one of the important applications of waste cooking oil is that in conventional, this biogas plants, if you utilize this waste instead of throwing away in the atmosphere or the drain, if you utilize it with the biogas plant, I can say not only the quantity increases, but the quality of this biogas increases, in which the percentage of methane will increase, right? So it is clearly that application of these conditions would yield 214 megawatt hour more in electricity per 1,000 meter cube of the sea-waste sludge digested. So at present, this can say we are not using the application, but certainly if the waste cooking oil is there, so that waste cooking oil we can utilize it for the case of biogas, biomethane enhancement of that one. In my earlier, you see, a couple of lectures I have delivered in the DTU and various places. Then I have told that we can have a retrofitting of this ultrasound converter, where this whatever the mixture you have prepared, the mixture will pass through this one as a retrofitting. In that case, what happens? If there's a biomass or any other quantities are there, then the lignin and other lignin and cellulose, hemicellulose, they are just separated, and in a better way, they will just have more, can say, the bacteria can eat them in a faster rate. If it passes through a cavitation technique, the results I have shown that it is quite improved. In a similar way, if you add the waste cooking oil with glycerol, then these results will be further improved. People have checked that one, right? So biogas is a very good source, but at the same time, you can enhance the capable quantity as well as quality by using these cavitation techniques, where ultrasound or can say microwave or various combination of these techniques can utilize. The technology point of view, improvement in the yield. At the same time, if you add this waste cooking oil into waste cooking oil in the sludge itself, right? The CPS sludge. Even in that case, your quantity of output will be improved. That is the main important point. Biogas is again a fuel, so therefore it can be utilized, right? So that's a novelty. Now, from feedstock point of view, we all know that WCO is readily available, has low feedstock, demonstrates high product yield, and environmental friendly, right? So now, the techniques used to convert this waste cooking oil into biodiesel, we all know that there are hydroesterification, acoustics, and hydrodynamic cavitation, ultrasound, high intensity ultrasound, ultrasound irradiation, electrolysis. Electrolysis is one of the recently developed techniques that I will discuss a little bit more time. And all these techniques in my earlier lectures I have delivered, so I will not take much time on that one. Now, the advantage of these techniques is that these techniques generated high quality products that meet international specifications under moderate operating conditions. Whatever the final product, biodiesel synthesized from WCO, it should match with the ASTM standards and exhibits improved performance and lower emissions when compared with biodiesel from other feedstocks and conventional diesels. Right? So I have already can say in our DPU, it is summary of our work where waste cooking oil we have used. We have used this castor seed oil to improve the physiochemical properties. We have used the methanol as well as ethanol also. We have used two types of catalysts, KOH as well as calcium oxide. And the cavitation techniques, we have used ultrasound, we have used this microwave, we have used this hybrid reactor. And then almost in all the cases, we have optimized the parameters and then see that everywhere it is more than 90% yield we are achieving. Right? So scientifically, you can say we have got more than 90% yield, which is a very, very important outcome. Now, you see, majority of the people criticize that you are talking only in laboratory level, what to do with the, suppose, industrial scale, is it possible or not? Many controversies, many arguments are there. But I can tell you, French companies, Zeus and Hilcher, Germany companies, already they have manufactured big size ultrasound plants, microwaves and other things. But the moment you import them, they have becomes expensive. So our industries, our biodiesel industry or our industries will have to come out this ultrasonic industry, so that the big size ultrasound can be prepared. For example, here it is given, and also the other equipments are there. The various multi-frequency equipments must be there, and those have a big sizes. They are available at international level, and even if you just produce at national level, in that case, these cavitation techniques can become an integral part of the industry for fuel production. Therefore, the issue is the scalability issue. People always criticize this issue. Now, and recent times it doesn't exist, because you can go for a scale up with a very successful manner. And not only in biofuels, in other areas of ultrasound, one can go for scaling and other things. Of course, hydrodynamic cavitation are very scalable, where can say the alcohol plus mixture is there. We pass it through a pump with high pressure, and a nozzle device is there. In DTU also we have constructed this one, and then this particular thing, continuous circulation, will cause within 15 to 20 minutes, you can get a very good amount of biodiesel, 10 to 20 liters. We can produce it very fast. The cavitation, I can say we can use these ventures, circular venturi, or sometimes orifice also, so that the cavitation conditions are generated. Cavitation conditions means it is a formation, growth, and implosion of cavity bubbles. And you can see that when the liquid passes through this cavity, what happens? At the upstream side, the pressure is high, and downstream side, pressure reduces drastically, and then there is a recovery of the pressure. In those conditions, what happens? This formation of the bubbles, growth of the bubbles, and implosion of the cavity bubbles takes place to achieve high intensity of microemulsion and high level of micromixing in multi-phase reactors. So this reaction mechanism is a very important one, and normally you can see a controlled cavitation has wide range of industrial applications, not only in fuel, other pharmaceuticals and other non-energy applications. And therefore, this technology, people call it as a breakthrough technology, and experimentally they have proved that. Right. Another important technology for particularly used for fuel and extraction purpose it is used. First, I will talk about the applications: emulsification, homogenization, dissolution. Various applications are there. Where you see in this rotor stator technology, this rotor is moving, stator is stationary. In between, on the rotor, what happens? There are certain can say cavities are there, blind cavities. When this rotates around 3000 or 4000 RPM, then at the surface, what happens? The pressure becomes so low and cavitation conditions are generated. Means the the mixture is converted to vapor form, and it comes out in the form of a very, you can say, shock wave. So that's why this name of this whole apparatus is called as shock wave power reactor. And for mixing purpose or for reaction purpose, this is considered to be very, very good technology. So we are also working on that one, and one of our research scholars trying on that. Even small scale high speed reactors are very, very important, and they have become an integral part of laboratories. This, as compared to the conventional mechanical string where the RPM is 100 to 500 RPM, this can say the shaft rotates around more than 10,000 RPM, right? Again, in that case, what happens? The cavitation conditions are generated, and cavitation conditions are generated, and the reaction becomes very fast because all your can say OH ions and what are the cavitation conditions are there. Due to high rotation, what happens? It cuts the liquid so that cavitation ions and various redox ions are generated, which makes the reaction very, very fast. One is this opposite shaft, another is, you can say, this is a high powered household fruit blender where the shaft, you can say, the blades are on the upper side, in that case blades are on the lower side. Both have successfully demonstrated that biodiesel can be constructed. 500 ml biodiesel you can get within 10 to 15 minutes. Right. Another important technology is the in situ, means directly from the seeds we can extract the oil and convert into biodiesel. For that one, we can use this hybrid reactor. Hybrid reactor means you can say this is in situ mixture, then ultrasound is from bottom, and this microwave is from this side. So simultaneously, we can get the advantage of both the fields, whereas the drawback of these both the fluids are minimized in that case. And plus, the steps are also reduced, right? The elimination of oil extraction is reduced, and this will cause a cost reduction of around 70%, right? So microwave ultrasound has microwave it removes heat transfer barrier, whereas ultrasound removes mass transfer barrier. So that combination play a very, very important role. Even this product of this one, if it is we have imported from China, this is a very simple one, and the Indian manufacturers, if they manufacture it, it will sell like a hot cake. Another one, since you see, it is difficult that what happens, any metallic portion in front of ultrasound cannot come. It should be glass, right? And ultrasound, it is just like the bottom, this not horn type, you cannot use that one because the metallic portion and it will create a problem. So due to that reason, what happens, we are using this as a sequential, means first we have this tank. Through this tank, it will go to this ultrasound, then it will go to microwave, it is there, and then microwave again come to the tank. So this cyclic way it will come, it will pass through ultrasound and microwave continuously, so that you can say it can be controlled by biodiesel, and the results are quite good, right? I'm not going in details and other things because earlier I have explained that one. Only recently, only in 2021, in the Journal of Energy, it has come that even you can produce the biodiesel by means of electrolytic process, where the two electrodes are there. You can apply the DC voltage of 30 volt, and you can control the molar ratios and other things, voltage, and your co-solvent, what kind of co-solvent you're using. Based upon that one, you can get the biodiesel. So in the series of recently developed processes, this electrolytic process is also introduced, and this process can also play. But this process, till date, people are more focused on hydrogen production and other things. But now this process has also, like I say, applied for production of biodiesel itself. And you can see that biodiesel here, very clear biodiesel it is we are getting. So it is a recent papers, two papers they have come and they have demonstrated clearly into the papers are also recent, 2021, and they have mentioned that by using this electrolytic process, it is very easy to construct in the laboratory, and you can use it for biodiesel production. Now remember that even I can say for last 1 decade, I am involved in production of biodiesel, various publications, researchers, and patents and other things, right? So biodiesel is one application, right? But besides, through biodiesel route, we can have multiple applications. And remember that aeroplanes and these jets are, I can say, when they fly in the sky, a huge amount of mineral jet fuel is, I can say, consumed, even 20 liters per second or 10 liters per second, a huge amount. In that case, what happens? The CO2 emission is very high. Remember that in the sky, high CO2 emission means it has a severe impact on the climate change. Therefore, one should think about what should be the sustainable or green substitute for the case of jet fuel. So in that case, what happens? Even through biodiesel route, one can convert the this jet biojet fuel, and that biojet fuel can be mixed with the this conventional jet fuel, maybe 5%, maybe 10%, or maybe 20%. In that case, the total CO2 emissions can be avoided. So, WCO, because you see UP and other things, recently there was a conference on UP, and near the UP South where the new Jawar, where the new airport is constructing. So that will require that fuel, aeroplane fuel or jet fuel is required. So UP is a, you can say, agricultural state, and how they can convert the waste cooking oil into this fuel, and particularly biojet fuel, that's very important. The conversion of WCO into biojet fuel has gained attraction in recent years, and this is to maximize the availability and the low cost advantage of WCO and improve fuel combustion and the emission problems associated with the fossil based jet fuel, because huge amount of CO2 is emitted. So how to avoid that one? If you use a WCO and from WCO, if you convert it to biojet oil, that will be much better or sustainable. How to convert that one? For that one, the conventional methods are hydrocracking, the method people are using, deoxygenation methods are using, hydrogenation methods people are using, and it is and using those methods effectively convert WCO into biojet fuel. Further important aspect is that the biochemical properties of the product compiled with the ASTM standards, that is also compared with the standard jet A1 fuel. Right? So ultimately, the point is that when you blend something with the original fuel, the properties should not change. Then only we can consider that it is a substitute for the fuel. And the synthesis of syngas, hydrogen, methane from WCO. If you convert WCO to gaseous form, then the percentage of syngas, hydrogen, methane is effectively demonstrated where the generated syngas was composed of 70% producer gas, hydrogen, methane, and other gaseous fuels. Right. So conventional, easily you can say WCO, you can convert it to conventional fuel also in the gaseous form. Now, those areas where a huge amount of biodiesel is available, they are converting into jet fuels. For jet, nowadays, what happens, the jet fuel, every country is, can say, talking about the jet fuels. Here in the Middle East, not Middle East, it is South Asia, South Asian countries, they have a large amount of palm kernel oil. So using this oil, they are using one pot deoxygenation process, and through that process, they are producing the fuel or biojet fuel used in the aeroplanes and jets, right? So the production of biojet fuel from different types of palm oils, that is palm-based waste cooking oil, palm, olein, palm kernel oil, through deoxygenation process, you can easily convert into biojet fuel. People have used several catalysts, calcium oxide, zeolites, and PDYC, titanium oxide, and these are selected to investigate the efficiency of jet fuel-based hydrocarbon production under the 400 degrees centigrade for 2 hours with different catalyst loading. Because in experiments they do different catalyst loading and see that how the process can be optimized and the yield can be maximized. So this simple process in South Asia, people have just tried success, and they will come out in a big way. Even in our country, the point is that recently the policy has come where we have to grow the palm near the coastal areas. Once we grow the palm near the coastal areas, the meaning is that now the policies are favorable and we will get a huge amount of waste cooking oil if the palm oil is used for cooking purpose. Now, another important one is, okay, so the last application was related to, you can say, this biojet fuel, right? Now, these till now, whatever I explained, it is related with the fuel applications, right? Energy applications. But indirectly, there are other applications in which the most important one is the biolubricant. This huge, I have had the data which I have not included. A huge quantity of, you can say, this business is, can say, a business will increase related to biolubricant. Because at present, we are using the mineral lubricants and only the oil companies they are manufacturing. And since it is a byproduct, therefore they are encouraging to say byproduct of petroleum as a lubricants. But studies shows that biolubricant has still a lot of scope, because as the biodiesel increases, then through biodiesel route you can convert the biodiesel into biolubricants, right? And advantage of biolubricant is that biolubricant act as a anti-friction agents that offers low volatility, improved viscosity, better thermal tolerance, sustainability, and ecological amenability, right? When compared with petroleum-based lubricants. Normally, what happens? The objective is that at present lubricants are from petroleum-based. How we can replace them to biolubricants, that is a challenge, and at the same time, the possibilities always exist. Only the point is that commercial aspects as well as the life cycle aspects one have to consider. Biolubricants, if you just consider the properties, they are highly lubricity, biodegradability, and low volatility. WCO has been deployed as a low-cost base material for the production of lubricants. Right? Normally, how the lubricant is produced? Lubricant is chemical. The raw oil is chemically modified. The oxygen stability is improved, and biolubricant with excellent lubrication performance is achieved. Right? So it is a chemical modification is one of the important process, and in a similar way, WCO can also be converted into lubricant. The notable chemical modification routes for conversion of WCO into biolubricant includes hydrolysis, esterification, transesterification, halogenation. Means we know the esterification and acidification process, and these processes through biodiesel route you can convert the biodiesel into the lubricant. I'll just in the next slide I'll just show you the reaction also. So the main meaning is that WCO offers cost-effective, readily available, sustainable, and environmental-friendly feedstock for biolubricant production. And biolubricant is also, since in our country the huge amount of vehicles are there, the industrialization is there. Wherever there is relative motion between the two components, then always one have to use the lubricants. And if you use a biolubricant, then this is as per the nature's law. So, WCO can be catalyzed, chemically modified, and converted to biolubricants. So biolubricant has a big business in this decade. This is a simple process I want to show how to convert the biodiesel, this waste cooking oil into the lubricant. There are two routes are there, two steps are there. In the first step, triglycerides are there. by using the methanol, you can convert glycerol and methyl ester, right? This is biodiesel route, classification process. So we have got this methyl ester means biodiesel. Now, in the second stage, what happens? This trimethylon, can say this, here he has used rapeseed, we can use the waste cooking oil, no issues. Waste cooking, this is a biodiesel of waste cooking oil. If you react with the trimethyl propane, right? We will call it as tempte. So if they react with this one, then this portion of TMP, that is tempte, uh, triester, it is produced, plus methanol is produced. So this quantity is known as the biolubricant. Now, if you manufacture for conventional processes, then 140 degrees centigrade to 200 degrees centigrade temperature is required. Some boiling is also required. But here the point is that this particular study, which I am mentioning here, only ultrasound is utilized at nearly 70 to 80 degrees centigrade. You can use the ultrasound, and through this one, what happens? We can produce this biolubricant from this one. So answer is that biodiesel not only can be used as a fuel, but at the same time, if you convert biodiesel into biolubricant, its cost will further improve, or we can have commercial viability exist. That is the main point I want to say. And even in conventional techniques, what happens? We can use this cavitation technique instead of the mechanical stirring technique. Here, the meaning is that it's a two-stage transfiguration reaction for trimethylol propane trimester synthesis from triglyceride. You see, there is a long. I was also surprised when I collected I can say, the different applications. All processes, you see, we are not aware that only up to, as engineers, we are only aware of that it is applicable for biodiesel. No, it has other applications also. And besides the last one, which I have discussed, the new one is bisabolene. It is having can say chemical formula C15H24, and this bisabolene is found in plants and is used in beauty care, chemical, pharmaceutical, medical, food, flavor, and fragrance industries, right? So it's a very, very important component, and this is used for a wide range of applications in the industry. So therefore, how to extract that quantity? A choice to biosynthesis bisabolene from WCO offers many advantages, including high yield, low cost, and environmental friendly process, right? And application of WCO as a feedstock for the synthesis of bisabolene is still relatively new, and reported cases are very limited. How to extract that one? It requires, there is a need for more investigations to explore this important research gap. Only a couple of papers available in can say on the net, and more detail is required for that one. I'll not go in detail, but you can see that this particular recently a concept of proof people have developed using this one, where you can say waste cooking oil is there, and various microbiological steps from this one. You can get alpha, beta, gamma, bisabolene, right? These are all important components related to bisabolene, right? So these are the steps one have to follow, and then you can achieve this particular, you can say, this very, very valuable product, and can give you money. So how to abstract that one? A startup or any small experimental laboratory can be opened, and the funding will be very, very high if you are successfully produce this particular bisabolene product. If you can abstract separately, it will be very, very huge contribution as well as impact on the society. Okay. Now you see, fuel I have explained, biolubricants I have explained, but still there are very, very simple, can say, examples are there which can play a very important role. Even we know that vegetable oil can be utilized, vegetable as well as non-edible oil, both can be utilized for converting into the hard soap, and which are using, right? The soap industry, they are purchasing. But even then, there are still, you can say, the simple methods are available in which you can produce the detergents, dishwashing soaps, and aromatherapy candles one can produce. These are very important products, particularly from a festival point of view, right? So people have reported in the experiments that QH can be thoroughly mixed with WCO as a low-cost base material, and it can produce a dishwashing liquid soap for household. That's a very simple. Just addition of QH, WCO, a typical FFA content must be less than 0.3 or 0.2, and then you can add a requisite quantity of QH, can be mixed with WCO, or what is the result? Result is a low-cost based material to produce dishwashing liquids, liquid soap for household purpose. So in South Asia, people are just develop this one and compare the final product with the standards available. And it's from Indian point of view, it is a cleaning or hygiene of the health hands are very very important, even in COVID era as well as post-COVID era. Now, desirous of converting WCO into a more useful and better quality housing company, household company, mixed WCO with activated charcoal. Activated charcoal has a wide range of applications. I'll talk later on. To produce aromatherapy candles, right? It's a very important one. WCO was used for medicinal purpose rather than allowing it to be disposed of inappropriately, thereby generating unpleasant odors and pollution in the atmosphere. The moment you, I can say, burn it in an unpleasant manner, a lot of pollutants will be generated. But if you utilize it for beneficial purpose rather than allowing it to be disposed of inappropriately, thereby, so it can have, give a very good answer for all these cases. The one important thing, I'll just say, if I have details, I have details of that one. You can try that one. This soap, and how to clean the dishes. For that one, we can have a liquid soap we can produce. It's very simple. 100 gram of waste cooking oil with QH concentration of 22.5%. You have to mix it still using the hand blender for 45 minutes. After that, water is added with the ratio of water. Soap is two times and one is the water. Still against 3 minutes, then add coloring. You can add the colors in the liquid soap. You can add the perfume as much as 2 ml. Then stir for 2 minutes. Then further you can stir for the 2 minutes. Right. Then the final product is ready. So it is not a rocket science. Because it is an hard program suits at the same time. The cleaning and other things, they are also important from government point of view. So certainly the government will assist. This is the methods which I have collected is from, you can say this is from Indonesia, Malaysia, and those countries where the palm oil is used in a very, very high quantity. Now, another important one is, you can say it is plasticizers, right? Here, the lecture point of view, I'm not going into details of that one, but you should be aware of that. What are the wide range of plastics is an integral part of that one. And what is the prediction of plastic for this? I can say in the market report, around this, total global forecast is at 21.3 billion US dollars up to 2027 at a CAGR of 5%. It means the plasticizer business is a very, very big business, right? So WCO can be effectively utilized for production of plasticizers and can be used as additives in the plastic industries, right? And food packaging and toy manufacturing. These are all plastics play a very important role. You can use the WCO can be added as a plasticizer. Why it is needed? Because increased demand for plasticizers in the last decade and the negative effects of petroleum-based plasticizers, that is the main issue, has made the research for a viable replacement inevitable, right? You see, this diethyl phthalate plasticizers poses considerable toxicity risk to children and pregnant women when consumed, and this has necessitated some countries to ban these use of in plastic food packaging and production of toys, and consequently shifted attention to non-toxic and environmentally benign bio-based plasticizers. Therefore, huge possibilities are there where you can utilize the waste cooking oil for bio-based plasticizers. Which method? Method is also epoxidizing bio-based plasticizers from waste cooking oil. This is a very, very simple process and easily one can do it. And the technique they can use either mechanical stain or they can use it cavitation techniques, right? So it has reported that by this process, if you use the biodiesel, in that case, the plastic, which is plasticizers which are formed, their properties are improved, and those properties are mechanical properties, thermal stability, flexibility, higher oxidation stability, enhanced local temperature performance as compared to conventional plasticizers. So plasticizers are huge and big business, and therefore one have to try the possibility that we can use the waste cooking oil in the plasticizer to improve the properties of plasticizer. Researchers have a consensus of opinion that WCO-based plasticizers pathway is considered as a cleaner, safer, and cost-effective routes for the plastic industries. And of course, in this direction. Before we finally go for commercial, more researches are still needed to devise more novel and greener ways for the conversion of WCO into bio-based plasticizers. But certainly there is a scope is there. Another important component is the polyurethane, which is a very commonly used in our houses, beds, and your sofas. Another thing we are using. The production of PU, that is polyurethane foam from edible vegetable oils and petroleum-based polyols and uh, uh, polyisocyanates have continued to be a serious concern because researchers found that it has a very high cost in case of petroleum products, reliance on the food products, and the attendant environmental degradation arises from the exploration of fossil fuels, right? So therefore, this substitute material for this PU must be from the sustainable form, right? In this aspect, the use of WCO as an alternative feedstock for the production of polyurethane foam is seen as a way of solving the growing concern. Further, in other studies, WCO as an alternative feedstock for the production of PU foam is seen as a way to solving the growing concern, right? Classification methods to synthesize polyol WCO, a bio-based feedstock, and therefore, before using the WCO, it was absorbed by coconut husk activated carbon absorbent. This is required, right? The point is that the polyol derived from WCO is used to prepare rigid PU, that is polyethylene. The WCO derived PU is seen as a sustainable replacement for the petroleum based PU and viable material for thermal insulation panels and house construction materials. So, even in that case, no need to go for every time for biodiesel. Even polyurethane based cooking oil can be used with some pretreatment, right? If you require absorbent, so you can use activated sugarcane bagasse can be used as absorbent, and it can be used with WCO as a feedstock for classification of WCO. The resulting product was found to be cheaper and more attractive with superior physical properties than the commercially available PU. Right? The people across the world they are coming, and a similar research synthesized polyol and used biopolyol for the production of open cell rigid PU foam. The valorization of WCO into PU achieved by epoxidation, production of polyol and forming of polyol to get bioforms. BioPU has better impact strength, tensile strength, elongation, and break, water absorption, sound absorption properties, and performing better than the petroleum based. Because the whole exercise is that whatever the petroleum based, can say this polyurethane we are using, we have to replace it by waste cooking oil, right? So exactly when you want to go to for commercial purpose, then the point is that many investigations are required to devise more innovative and cost-effective routes to synthesize PU from WCU. So this is also a very important application. Another important application of the point is that this is, you can say, it is surfactants. Surfactants, remember that it is used to reduce the surface tension. The petroleum-based products that have sulfurate groups for the reduction of the surface tension between liquid-liquid combinations, liquid-gas combination, or liquid-solid phases. So that's the main purpose of the surfactant, that it reduces the surface tension. And till date, you see, we are dependent on petroleum products, right? So to reduce the dependency on the petroleum products, the environmental impact of the feedback and the production process, the use of renewable surfactants has been suggested. And which is the most suitable renewable surfactant? The renewable surfactant is the methyl ester sulfonate, MES. MES is considered the best surfactant. And how you can produce that one? The WCO can be converted into MES involving the pre-treatment of WCO, transesterification of treated WCO into methyl esters, and conversion of methyl esters into MES using sodium bisulfate and HSO3 as a sulfuric agent. In that case, the next two steps, first step is transesterification, and the next step you can convert into surfactant, right? And surfactant play a very important role in petroleum industry. So another important, I can say, use is that researchers synthesized cationic Gemini surfactants using WCO as feedstock to be used as a novel corrosion inhibitor of N80 steel, right? That biodetergent developed from methyl ester sulfonates surfactant using WCO as feedstock and titanium oxide nanoparticles. These are the catalysts, right? As catalyst. Both the MES and the biodetergents were found to be better and performed more than those synthesized from the petroleum-based product. So only the main challenge is that what are the petroleum products are there for surfactants, how they can be replaced by using the sustainable surfactants using waste cooking oil. Still, there are challenges are there. The valorization of WCO into biosurfactants is still a developing research area. More targeted research are needed to develop improved and innovative pathways for processes. Right. So, in this way, greener techniques for the conversion of WCO into bio-based surfactants are needed to explore its wide scope for industrial applications. These are the new avenues where waste cooking oil can be converted into the finally, you can say, much value-added products. Yes. Civil engineering example point of view, it is asphalt, that is regenerator, it is there. And remember that, just like you can say damper and this concrete is mixed, so that is called as asphalt regenerator, means how you can improve the life of that asphalt. Globally, around 120 million tons of asphalt pavements are crushed for various construction activities, particularly in our countries. The road activities are going on very fast. Reconstruction, resurfacing, rehabilitation of roads annually, a very huge activity in our country. So recycling asphalt pavements is beneficial to the construction industry from the energy saving, economy, resource allocation, and environmental point of view, right? So whenever the asphalt pavement becomes aged, when they are exposed to weather and subjected to persistent traffic loads. In this situation, the binder that is a regenerator, loses its viscoelastic properties and makes the asphalt pavement susceptible to cracking and breakages and needs to be regenerated, right? So how to improve their life? Regeneration of asphalt is the process of reviving aged asphalt by restoring the ratio of asphaltenes and maltenes, right? These are the two important as a ratio we have to consider, and that can be achieved by addition of regenerator or binder, right? So, what is the regenerator? Yes, your waste cooking oil is available. Recently, waste cooking oil applied as a sustainable alternative to ameliorate the high cost and the environmental impact of the replacement of petroleum-based regenerator or binder. Petroleum-based means they are not sustainable. At the same time, the cost is high. But the point is that since they are the byproduct of the petroleum, the people are using. So now in the future, what happens is the petrol products will be reduced. How to substitute those, can say, non-sustainable products by means of sustainable products such as WCO. Further, it has been reported that addition of treated WCO to asphalt increases its stability, modular stiffness, tensile strength. These are very important properties from civil engineering point of view. Intermolecular adhesion and low rutting deformation when compared with petroleum-based binders, right? So whole issue is that how this asphalt can say with binder is from petroleum industry. So how that binder or regenerator can be substituted by using the waste cooking oil to improve the life of the asphalt, because huge quantity of asphalt every year annually it is used. This is another important application of waste cooking oil, right? Now, this is the can say till now, this is the exhaustive list of directly you can use the waste cooking oil. Now I am talking the last 5-10 minutes. I'll just talk about this one. Industrially, as we know that 100 kg if you produce the biodiesel, then 10 to 12 kg it is a glycerol is produced. It is not a small quantity; it is a very big quantity. So if you can whatever the glycerol it is produced, we can call it as a crude glycerol. And if you make a refined one, then you can call it a glycerol, refined glycerol, right? So both the glycerols have a wide range of applications, and we should know that how these byproduct of biodiesel can be utilized for industrial purposes. So even in the United States, a lot of research is going on because those who are pioneers in the case of biodiesel production, they have that excess quantity of this byproduct. And how to utilize that one, that is still a challenge, and they are working in that area. That why not we can use this as a fuel as well as many other combinations they can be used. So here, this is a recently developed because this is, MIT is also involved in that case, and they are just trying the other avenues where glycerol can be utilized in terms of fuel and fuel additives. From that point of view, they are working in that area. So crude glycerol has attached much attention as a major biodiesel byproduct, accounting for 10% of biodiesel produce. Means 100 kg biodiesel produced, then more than 10 to 12%, 12 kg will be the glycerol. Main, unfortunately, you can say crude glycerol is considered a low value product because its impurities and large varieties of its components. Those impurities are there, right? And removal of impurities processes are available, but they are expensive and make the product, final product, very expensive, and therefore the commercial viability reduces. So now, I can say in a new, fresh insight, the researchers are doing efforts in which they are exploring value-added uses of crude glycerol and its major components. And its major components, glycerol for maximizing the economic and environmental benefit of the biodiesel industry, right? How with the biodiesel industry it can be utilized, right? So there are various approaches are there, and using those approaches, crude glycerol and glycerol as combustion fuels in straightforward, they can directly used in the, like I say, the nozzles, has great potential in applications, including power and heat generation, that is the boilers, they can be used, and material synthesis, that sometimes what happens, very value-added materials can be synthesized from this glycerol. This not only benefits current combustion systems, but reducing the consumption of fossil fuels. Partly, you can reduce the consumption of fossil fuels, but also adds renewable features, aligning with the current trend for developing carbon neutral energy systems. Because you cannot replace the fuel, but at the same time, if you use the glycerol as a fuel, in that case, partly reduction of conventional fuel can be reduced, and in this way, you can say you can help in assisting carbon neutral energy systems. Crude glycerol, what happens? A mixture of glycerol and other impurities are there, and this surprisingly shows good flexibility as an independent fuel, as well as it can be used as a fuel additive for liquid gas combination, liquid liquid combinations, and liquid solid combinations for power and heat generation. So, as a fuel and fuel additives, the crude glycerol can play a very important role, and in the United States, leading universities and manufacturers they are working in that area. So therefore, in the recent years, great efforts have been placed on topics including advancing of the understanding of fundamental combustion features, improving combustion designs, because they have to design these filters and nozzles according to the requirement of, if you add this glycerol, in that case, slight modification will be required, and operating parameters will be slightly varied, and exploring new use of crude glycerol and glycerol for combustion applications, because in that case, it is a sustainable fuel, and you can replace the this conventional fuel into sustainable fuel itself. Right. This is a summary of, you can say, the crude glycerol, and the solid line is for direct use, and the dashed line is for indirect use. You can see that crude glycerol, which includes a mixture of glycerol, methanol, water, ash, soap, salt, and non-glycerol organics are there. So you can use this one. And one direct application is that you can supply it for animal feed. Indirect application is, you can say, gasification process, where syngas, hydrogen, ethanol, biochar, bio oil, you can use that one. And thus the crude glycerol as a renewable source of energy applications, you can use it, right? You can supply it for fuel and fuel additives also you can utilize. Directly you can supply it for solid fuel, you can mix with the solid fuel. Remember that if it is mixed with the coal, the NOx formation is reduced. Why? Because it is oxidative in nature. That is a very, very important can say achievement. You can use it with gas fuel, you can use it with liquid fuels. So people are doing experiments and they are using better efficiency in power and heat generation, and combustion materials through synthesis they are just achieving. Other indirect application dash lines are fermentation, liquefaction, and polymerization, esterification, transformation process, where these are the various processes taking place. And finally, we can come out with the value-added chemicals, which are quite valuable as well as suitable for the case of industry point of view. So this is a typical flow chart I have given for crude glycerol, through which you can produce various byproducts, and you can apply it with the fuel to get the heat and power. The same thing you can, I will not go again in details, but the point is that if you refine glycerol, your performance will improve. But the main issue is, the challenge is that the moment it is you refine the crude glycerol to glycerol, the price will be high, right? So even glycerol can also be placed in the same applications which we are using the crude glycerol, because crude glycerol is available much cheaper rate as compared to the refined this glycerol. Now, another one is that you can say this crude glycerol as fuels and fuel additives in combustion system. Directly from the combustion, you can use it, right? say for example crude glycerol, you can use it for independent fuel. Any independent fuel you can use it independently as a fuel. You can use it, right? Because it has a calorific value, but it is lower than the coal. It can be mixed with the natural gas, and co-combustion will take place in the boilers. It can be mixed with the coal, and people found that there's a very successful in our country. Remember that coal is a very low quality, right? If you mix the this glycerol, in that case the quality will be improved as well as the pollutants quantities are reduced. That is the main advantage. It can be used as a coal slurry, hybrid coal, co-combustion. You can utilize it. Similarly, since it is a sustainable product, you can mix with the biomass where briquettes can be formed, and those briquettes, when you burn it in this biomass burners and other things, where pellets, slurry, and co-combustion form, it is there. So even in that case, we can use in the boiler and boiler furnaces, right? So these crude glycerol directly as a fuel, can say as fuel and fuel additives in the combustion systems has successfully they can be used. Only the point is that one have to look out the commercial as well as techno-economic aspects. Of course, glycerol again the same thing. Can say glycerol, what happens? It can be utilized in independent fuel, natural gas, coal, biomass. This is already the same. Besides this one, glycerol people have tried to mix with the ethanol, right? Which can be blended with the and engine efficiency. They have seen that it is not affecting any engine efficiency. Similarly, this glycerol can also be mixed with diesel and biodiesel gasoline, and emulsion is formed. And through this emulsion, it can be injected into internal combustion engine. That is a diesel engine. You can inject that one. Even then, the results are quite good up to a certain extent. Point is that even a liquid fuel, if it is used, it is important. So glycerol, a lot of can say from research point of view, a lot of can say work can say it is possible to convert into value-added products directly applied for application purpose, right? With this one, let me summarize for last 3 to 5 minutes. Normally, can say just like me, can say a couple of months back, I was considering that waste cooking oil can only be replaced for biodiesel only, right? This is not true. So from this lecture, I can say I have proved that WCO is a low-cost and environmental friendly base material for the production of aromatherapy candles, liquid detergents, dishwashing soaps for small-scale applications. But for our country, this dishwashing and other things are very important one. A very important product, bisabolene, valuable raw material for industrial applications, can be synthesized from WCO. WCO can be used as a cheap and eco-friendly feedstock for plasticizers, polyurethane, that is PU foam, surfactants, asphalt regenerators. The huge number of applications with, I can say, a lot of potential for business it exists. More researchers are needed to devise more innovative technologies for conversion of WCO into more useful products. And of course, I have forgotten to mention the lubricant, biolubricant. Now, the main issue here is that the cost factors and environmental benefits of different approaches largely hindering the future development of crude glycerol and glycerol utilization. Because glycerol is also a biodiesel route, it is a byproduct. So, whatever the biodiesel is produced, more than 10% glycerol will be produced. Therefore, economic and life cycle analysis are necessary to evaluate the economic and environmental features of different routes and provide practical application guidelines, both for the case of glycerol as well as for the case of biodiesel. So life cycle analysis with commercial aspects and your economic aspects, one have to judge it. And of course, environmental aspects are integral part. With this one, let me complete my lecture with future applications, right? So world is looking for a material, and now it is an era of industry 4.2, 4.0. So in that case, what happens? This can play a very important role, and WCO can be one of the most cost-effective and readily available material to fill the gap. High cost of biofuels are there. I can say that can be substituted, because you see raw feedstock always have a cost. So WCO is a cheaper feedstock that can be replaced for, and that can be affordable, and particularly for rural dwellers and local farm owners, it is much easier, right? And the era of inappropriate disposal of WCO should be reduced, and it should be greatly affected, because otherwise what will happen? It will greatly affect aquatic habitats by polluting and distorting the aquatic ecosystem, and some of the sea animals going into extinction. So all these drawbacks, once we properly utilize this incentivized WCO collection, and this will reduce the amount of WCO disposal to harm the environment. So it means that we have to use it proper way, and we should not spoil the environment by just spreading the drains and the drainage as well as the seeds. So the practicability and sustainability of concepts of waste to wealth, W to W, is very important. Waste to energy, W to E, can be achieved and escalated if more attention is focused on WCO as a resource, right? While there are some avenues for converting WCO into useful products, the biotechnological channel is more feasible and environmental friendly, right? These are some of the implications, and another one is that the conversion of WCO into energy and its contribution to achieving a cleaner environment will assist its meeting some of the SDG. Remember, the SDG means Sustainable Development Goals, and among those goals, we know that generation of energy, collection, conversion, utilization of WCO, the journey towards a circular economy will be much faster and more realizable. The waste management, waste disposal, waste minimization, waste reduction, and zero waste will contribute to a cleaner, safer, sustainable environment and ultimately healthier people. So whatever the applications which I have told you, in that case, there's a need for the research, and if you do the proper research, then there are commercial angles are there, and at the same time, they have a tremendous impact on the future economy also, right? Couple of more points can say for to achieve the target, conducive can say policies are required, innovative pre-treatments and conversion technologies are required, which are also developing simultaneously, and more targeted and vital research on the collection, transportation, purification, and utilization of resources is needed, and the introduction and enforcement of subsidy policies, life cycle assessment studies, and monitoring of dangerous emission during biofuel production and other WCO conversion processes will further improve the utilization potential of WCO, right? And at the same time, the government agencies, private sectors, operators, other relevant stakeholders, they should come together and they should join the awareness campaigns and sensitization for the conversion of WCO to the household and industrial products, right? The household products and industrial products, all these stakeholders will commonly have to work, right? So main thing is that modern and innovative pathways for biotechnological conversion and utilization of WCO should be exploited to reduce the impact of inappropriate disposal of every increasing WCO generation, because it is continuously that WCO will increase, and therefore we have to devise the methodologies through which how we can convert WCO into useful or very valuable products, because it is continuously growing industrial sector. No doubt, WCO will contribute in no small measure to the realization of the circular economy. So, circular economy, what happens? That WCO is an integral part, and we have to think in a very rational way how in the future WCO can be converted into fuel applications as well as non-fuel applications. Both are very, very important, and the techniques we have to develop, we should be energy efficient, commercially viable. At the same time, they must be environmental friendly. Okay. These are the couple of biodiesel technologies we have developed in our centers. I have shown so many times, but now we also want to enter that biodiesel is not the only avenue. There are multiple avenues are there, and through biodiesel route we want to appear into the different fuel applications, other fuel applications as well as non-fuel applications. Right. The main thing is that ultimately it is a spirituality covered to the matter. Look deep into the nature, then you will understand everything better. Depth is required everywhere, and long-term policies are important. This Bhagavad Gita can always give the guidelines and throw some light for our journey. Once again, thank you, the organizers, sir. Thank you, my friend, Dr. Paul. Thank you, all the organizers, listeners, and other things. And it is really a great experience to talk in front of August gathering. And I wish that this program is a great success, and continuously the DTU will rise to the occasion, and they will be a part. DTU will be a torch bearer to organize such kind of programs to create awareness about the energy, and being a premier institution in the country, it has its own role, and they are fulfilling in a great way. Once again, thank you all, and wish you the season's greetings, and wish you all the best, and please take care about your health and nears and dears, and hope that things will become positive in the future. Thank you all. Thank you very much. Over to you, sir.
Thank you, sir. Thank you very much for your very exhaustive lecture. It has covered everything left out in the biodiesel. It also gave a lot of insight to the people who will be attending for getting their research interest area. So this is a very important area. I was thinking to leave the biodiesel because of feedstock problem, but there are so many applications in this field, and it is also a very good alternative. Just keeping aside the proper planning we need to done for the proper availability of feedstock. Now house is open, and we also welcome Sri H.K. Agrawal ji. He has joined for our next session. He is an alumni of DCE, Delhi College of Engineering. Welcome, sir. Here to unmute. Yeah.
Thank you, sir.
Welcome, sir. Yes, we will start in around 5 minutes. Let us have some discussion on sir's lecture, and then we will join. Yes, house is open.
Sir, your topic is very interesting, really, and very excellently you have presented your topic. But sir, there is one query कि ये जो कुकिंग ऑयल है इसको जैसे आपने अमूल दूध का गुजरात में किया था उस तरीके से कोई कलेक्शन की स्कीम बनाएंगे क्या आप बाद में, क्योंकि एक्चुअली हाउस होल्ड लोगों से आपको कलेक्ट करना कुकिंग ऑयल का, वेस्ट कुकिंग ऑयल का, वो तो थोड़ा सा डिफिकल्ट है। होटल्स वगैरह से तो आप कलेक्ट कर सकते हैं एक स्कीम बना करके, लेकिन कुछ लिक्विडेटिव स्कीम ऐसी बनाएंगे क्या आप फ्यूचर में, गवर्नमेंट बनाएगी कि जिससे आपके नॉर्मल ये जो अपने घर के लोग हैं वो भी अपने कुकिंग ऑयल जो वेस्ट कुकिंग ऑयल है उसको कलेक्ट करके दे दे?
You see, in Gujarat, not only Gujarat government, कई सारी गवर्नमेंट्स है जिन्होंने अपना स्कीम बना रखा है कि दे हैव ए ऐप related to waste cooking oil. So in that app, if you download that app and mention that I have 1 liter or 2 liter or 5 liter, this waste cooking oil is there, and the rate is fixed. So government agency will come, the vehicle will come to your home, and they will pay you 30 rupees per liter. So this is the government price through which you can sell this waste cooking oil if you have collected. So of course, this is the government agencies are there, but still people are little bit shy and other things. So point is that government agencies, their planning is very good, but the response of the customers still it is can say it is difficult for household that once we have used the oil, then it is difficult to understand that why can't we use it for second time. But the second time application after frying something, it is very can say not good for the health. तो थोड़ा अवेयरनेस क्रिएट करना पड़ेगा एंड एट द सेम टाइम कैसे गवर्नमेंट एजेंसीज को भी थोड़ा सा एक्टिव होना पड़ेगा. बट सर्टेनली दिस सस्टेनेबल चेन इज देयर वेयर थ्रू ऐप you can collect the waste cooking oil through normally all these your can say 5-star hotels, McDonald's and other things, they are selling like this to the government agencies.
Okay, sir. Thank you, sir. Thank you.
Thank you.
Sir, for your kind information, already in Bombay, some NGOs are there. One of them are RUCO. RUCO has already implemented many such programs for collecting the household waste oil, and they are making reconversion, and they're already doing it in very successfully in Bombay and Pune, both places.
Yes, I have forgotten the name of RUCO. Yes, RUCO is the app through which one can download and can do that. Yeah.
Yes, anyone else? Please, last comments. So I think we are reaching to 4 p.m. exactly. If there is no question, then we will be concluding this session. Thank you, Professor Kachhwaha. And if you have time, please join us in the concluding session also. We will be very happy.
At what time you will start the concluding session?
Within 2 minutes, sir.
Okay, I'm there online. Yeah.
Okay. And thank you very much for your continuous support. Always we remember you, and you always taking part in our programs with full enthusiasm, like a DTU part.
Yeah.
So once this pandemic is over, definitely we will be again meeting in physical form, and we will enjoy tea and snacks together with you and have some more discussion on these research areas. Our students are also missing your physical presence. Thank you, sir. Thank you very much. Yeah. Thank you, all the participants. Now we will be, yes, Neeraj or Subhaditya?
Yes, sir.
Yeah, we will be going for next session. Okay, have you prepared that slide for Sri Agarwal ji? Yeah. Okay, just a minute. So, dear participants and all my faculty colleagues, let me introduce Sri H.K. Agrawal ji, Harsh K. Agrawal ji, who is an Delhi College of Engineering alumni and is active in research and contributing to the society. We all see that electrical vehicles are coming to help us to mitigate this problem of exhaust emissions. And for that, a lot of research work is needed. So, Sri Agrawal ji will be sharing some of experiences in this field, how we can develop the electrical powertrain, how we can develop the electrical vehicles, and what are the difficulties that may arise to develop the high energy efficient electric vehicles. Welcome, sir, Sri Agrawal ji.
Thank you so much. Honorable members, I am alumni of Delhi Polytechnic. DTU or Delhi College of Engineering is a part of the whole complex. This electric vehicle system, it started in India about 100 years ago. Trolleybus and trams were quite common in Bombay, first time it came. In Europe, particularly UK, they came first with battery operated vehicles and electric trolleybus. Originally, their underground train system, metro system, was based on